Okay, so hello everyone. In this video, we will cover introduction to scheduling algorithms and FCFS. So in this video, we will first discuss scheduling algorithms, then different times like burst time, turnaround time, completion time, and etc. And then FCFS, first come first serve. Now moving forward to scheduling algorithm, it is a way of selecting a process from the ready queue and putting it in the CPU. According to the degree of multiprogramming, we try to keep multiple processes in the ready queue, and the ready queue lies in the RAM. We use different queues in the operating system to execute processes and bring as many processes as possible into the ready queue. Since the ready queue lies in the RAM, when I have a lot of processes in the RAM, I need to execute those processes. To execute them, I have to select processes among them and execute them on the CPU. If we assume that we are using a uniprocessor system, meaning we have just one CPU, then one CPU can execute one process at a time. So what criteria can we use to decide which process should be executed? That's where scheduling algorithm comes in. They help in determine which process should be executed for how much time and what is the order of that process is coming. So that is scheduling algorithm decides. Now preemptive versus non-preemptive scheduling. Broadly, scheduling algorithms are two types: preemptive and non-preemptive. These terms are used extensively in scheduling algorithms and appear frequently in numerical problems and operating system. So what is preemptive scheduling? In preemptive scheduling, if I take a process from RAM and place it in the CPU for execution, it's possible that while the process is running, I can pick up that process during its running state and place it back into the ready queue. This means I can stop a process that's running properly and give some other process to the CPU, placing the first process back in the ready queue to be executed again, like placing the first process back in the ready queue to be executed again later. Now what is non-preemptive scheduling? Although we have discussed all these preemptive and non-preemptive terms in our previous video, you can check it out, but I can explain it to you in this video also. So what is non-preemptive scheduling? In non-preemptive scheduling, if we take a process from the ready queue and give it to the CPU for execution, that process will be completely executed. The entire burst time will be completed, and only after that we will bring new process to the CPU. So let me explain with this simple example. Imagine there is a class with 10 students and every student has a 5 question to ask. I am the teacher acting as the processor, and those 10 students are processors. Now in non-preemptive approach, I reach one student, take all the 5 questions, I will answer them completely, and then move to the second student and I will take all the 5 questions of second student. Now I will solve them and then I will move to the student number 3, and so on. In preemptive approach, I reach student 1, I take question 1 and 2, solve them, but when they are about to ask question number 3, I move to the second student. I take question 1 and 2 from student 2, and when they are about to ask question number 3, I move to the student number 3. Now what are the reasons for a preemption? First reason is time quantum. The CPU decide to execute a process only for a specific time period, say 2 seconds. If a process needs 5 seconds, I will run it only for 2 seconds and then place it back into the ready queue. This provides better responsiveness. If I take all 5 questions from every student, student number 10's turn will come very late, but if I take just 2 questions at a time, the last student will also get their turn faster. Now the reason 2 is priority. If I am attending to student 1's question and high priority process arrive, like let's say class toppers comes and ask me to solve their question, I might give more priority to them. I will ask student 1 to wait for a while. I will handle the high priority process first. Now the reason 3 is sorted job first, SJF. If one student want to ask one question and another want to ask 10 questions, I might handle the shortest request first. Now what are the types of scheduling algorithm? In preemptive algorithms, we have SRTF, shortest remaining for time first, LRTF, longest remaining time first, round robin, priority scheduling. So in this, SRTF and round robin is very important. You have to, like in GATE exam or university level exam, these two algorithms are very important, SRTF and round robin. Now what are the non-preemptive algorithms? FCFS, first come first serve, SJF, shortest job first, LJF, longest job first, highest responsive ratio next. Then we have multi-level queue, feedback queue. So these all are the non-preemptive algorithm. In this video we will cover FCFS, first come first serve, and in our upcoming videos we will cover all of these algorithms. Now important time definition in CPU scheduling. First is arrival time, AT. the arrival time, the time at which a process enters the ready queue, this is a point in time, not a duration. For example, if I enter a bank at like 11 o'clock to deposit money, my arrival time is 11 o'clock. Now what is burst time, BT? Burst time is the time required by a process to get executed on the CPU. This is a duration, not a point in time. If depositing money takes around 15 minutes, that time is burst time. Remember that arrival time was point in time, but burst time is a duration. Now the third one is completion time, the point in time at which the process gets completely executed. If I entered the bank at 11 o'clock but came out at 12 o'clock, my completion time is 12 o'clock. This is a point in time, not a duration. Now turnaround time. What is turnaround time? The turnaround time is the total time a process stays in the system. Turnaround time is equal to completion time minus arrival time. In the bank example, if I entered 11 o'clock and left at 12 o'clock, turnaround time is what? 12 minus 11. It is 1 hour, means 60 minutes. So what is waiting time now? Waiting time is the time a process waits in the system excluding its execution time. So what is its formula? Waiting time equal to turnaround time minus burst time. If my turnaround time was 60 minutes but the actual work took only 15 minutes, like then I waited for 45 minutes due to form filling or other delays. So that was waiting time, and my whole process took only 15 minutes, but I have to wait for 45 minutes. So this is what? This is waiting time. Now other than this, we have response time, RT, the time from when a process arriving until it gets the CPU for the first time. Formula is RT equal to time when process gets CPU first time minus arrival time. So in the bank example, if I arrived at 11 o'clock but started interacting with the clerk at 11:30, my response time is 30 minutes. So now we will discuss FCFS, the first algorithm, first scheduling algorithm. First come, first serve, FCFS. So FCFS works on the principle of arrival time. Whoever arrives first gets served first. It's a non-preemptive algorithm, meaning once a process starts execution, it won't be interrupted until completion. Now we have a numerical example. Let's solve a numerical example. You can see it on the screen also. We have processes P1, P2, P3, P4, and arrival time 0, 1, 5, 6. Burst time is 2, 2, 3, 4. These are the processes P1, P2, P3 and corresponding times. Now we have to calculate times. So we have to prepare a Gantt chart. So step by step solution using Gantt chart. At time 0 only P1 has arrived, so execute P1 from time 0 to 2, because this is burst time for P1, so we have moved to 2. Now the time 2, P1 completes, but P2 has already arrived at what time? At time 1, but so P1 has completed at 2, so execute P2 from time 2 to 4, because P2's burst time also is 2 plus 2 is 4. So now Gantt charts point at 4. Now the third is time 4. P2 completes. Now P3 hasn't arrived yet. Like it will arrive at time 5. So CPU remains idle from 4 to 5. Now time 5, P3 arrives and start execution from time 5 to 8, because its burst time is 3. So 5 plus 3 is 8. P4 has already arrived at time 6. So execute P4 from time 8 to time 12, because its burst time is 4. So 8 plus 4 is 12. So this is all about the Gantt chart. Now we will see calculations. So for process 1, what is the completion time? So for completion time, you have to see in Gantt chart that completion time is the right hand side time. So at P1, completion time for P1 is 2, and for P2 completion time is 4, because we have to see right hand side last time. So P2's completion time is 4 and P3's completion time is 8. P4's completion time is 12. So this is what? This is completion time. Now we have to calculate turnaround time. So we have seen the turnaround time formula. What was the turnaround time formula? Completion time minus arrival time. So we have to calculate P1's turnaround times. 2 minus arrival time 0. So it will be 2. For P2 turnaround time it will be 4 minus 1 equal to 3. P3's turnaround time is 8 minus 5. What it will be? It will be 3. And what is P4's turnaround time? It will be 12 minus 6. It will be 6. What is waiting time? Waiting time is turnaround time minus burst time. So we have to calculate it like for P1 it is 0, because turnaround time is 2 and burst time is also 2, and for P2 it is 3 minus 2 equal to 1, and for P3 it is equal to 3 minus 3 equal to 0, and for P4 it is equal to 6 minus 4 equal to 2. Now what is response time? Response time is we have seen that first CPU time minus arrival time. So it will be what? It will be 0, 1, 0, 2. For process P1 it is equal to 0, it is P2 for 1, and P3 is equal to 0, and P4 for 2. In FCFS we don't have to calculate response time, because response time is always equal to waiting time in FCFS, first come first serve. Now what is average turnaround time? 2 plus 3 plus 3 plus 6 upon 4. It is average time 3.5. Now what is average waiting time? 0 plus 1 plus 0 plus 2 upon 4. It is 0.75. This is what? This is average turnaround time and average waiting time. Notice that in non-preemptive algorithm like FCFS, the response time equals the waiting time, because each process gets the CPU only once. This covers the fundamental concept of CPU scheduling algorithm. The key is understanding the difference between preemptive and non-preemptive scheduling, mastering the time calculation, and practice with the Gantt chart to solve numerical problems effectively. So that's it for this video. We will meet in next video. Until then, bye bye.